This video is over Lesson 65, Circumference and Pi, and is for my 7th grade math class. So ladies and gentlemen, if I were to ask you what a circle actually is, I'm sure you could identify one if you saw one. I'm sure you could draw me one if I asked for it. But chances are you probably actually couldn't tell me what one was. So I'm going to help you out today, and we're going to start off with that. A circle is a set. Now remember, set here is just a math word that means a group or a collection. So it's a group or collection, a set of points that are equidistant. And if you break that apart, you can probably guess what that actually means. So equa sounds like equal, and distant sounds like distance. So equidistant means that they have equal distances. Equal distances. So it's a set, a collection, a group of points that are equidistant from a center point. So one point in the center and all the rest are the same distance away. So equidistant means equal distance. That distance is the length of the circle's radius. We call that equal distance radius. And the plural for radius is not radiuses. I'm sure some of you at home are saying it. Radii. It's one of those strange words that has a weird pluralization. So radii, we drop the US and we add an I. So we get double I there, radii. So again, a radius is any segment from the center of the circle to the actual circle. So what we see here is I have my circle, there's my center point, and I have a bunch of red radii here. So if we were to label these different radii, let's call this one, we'll call it A, this one can be B, this one can be C, let's call this one D, E, and F. And so remember that this is all equidistant. So A equals B equals C equals D equals E equals F. And so since these are all equal, we just sum this up usually with one letter, and we just call it the radius, usually just call it R for radius. So A is really R, B is R, C is R, D is R, E is R, F is actually R. It's all the same length. And of course, we could draw more in. We could draw an infinite number of radii in, and they would still all be the same length. We're going to move down now to the circle underneath that one. Our next vocab term here is going to be a chord, which you may or may not have heard of before in a circle. A chord is really very simple. It's any segment with endpoints on the circle. So if we look at this chord here, that's where one end has an endpoint. That's where the other endpoint is. Both endpoints are on the circle. So what you should notice here is a radius is not a chord. A radius goes from the center to the circle. But this has to go from circle to circle. Now, chords in general, at least for what we're doing here with this lesson, are really not going to be that important. They're not going to be that interesting to what we're trying to accomplish today. So I'm not really worried about just any chord. But there is a special chord that we do need to pay attention to. And that chord is the chord that goes through the center. It's actually the longest chord of the circle. If our chord, so from circle to circle, goes through the center, It's the longest chord of the circle, and therefore gets a special name, and some of you probably already know it. It's called the diameter. So diameter goes from circle to circle, but through the center on the way there. So all together, this right here is the diameter, and we usually represent that with the letter D. Now, if you look closely here, though, and we look at this circle over here, you may realize that if we take this diameter and break it up, I'm going from center to circle here. This actually is a radius. And then over here, this is center to circle again. That's another radius. And so we discover one of the more important properties of a circle, that one diameter equals 2 radii. And we normally represent this symbolically using the letters. So D, so a single D, equals 2 R's. D equals 2R. So if you want to find the diameter of a circle, do 2 times the radius. Moving on to our last circle here on the front. The perimeter of the circle gets a special name, and it's called the circumference. It's called the circumference. And now it's interesting that if you look, these circles are the same size, so the diameter of this circle would actually be the diameter of this circle as well. If you imagine taking a piece of string and cutting it off so that it goes from here to there, it goes one diameter here. It turns out that you could take that piece of string, and if we start right here, you could drape that piece of string over the edge of the circle and it would stop right there. So this would be one diameter right there. And I'd like you to grab a highlighter here. So, and we're going to just highlight this part of the circle. And we're going to highlight the word diameter there. So that would be one of this circle's diameters as a piece of string laid across the circle. Well, let's say we got a second piece of string that was the same length. It turns out we could get another diameter around the circle. And I'm going to grab yet another color here, different color highlighter. So this would be a second diameter that we could fit across our circle. And it would end right there on my circle. Well, as you can probably guess from our figure here, you could get a third string, a third diameter across our circle. Now this third diameter, as you can see, will not quite bring us all the way around. There's going to be a little bit extra. So it turns out that for every circle, you can get 3 of its diameters around the circle with a little bit extra. And the reason for this is that for every circle, the ratio of its circumference to its diameter is always the same number. And that number is going to be 3 plus a little extra, and I think some of you probably already have it in your minds. Now this number actually is kind of special. It turns out that you can't write it as a normal fraction, and you can't really finish writing it out, it goes on forever. It's not a repeating decimal, but it does go on forever. It's actually what's called an irrational number, because it goes on and on forever without repeating. Now, we can't write that. We can't keep writing forever. So when we run across numbers like this, what we do is we use a symbol that represents the entire number all in that one symbol. And the symbol we use is pi. And so pi starts with a squiggle top, just like that. That squiggle right there. We've seen this squiggle before in our approximately equal to signs. And then it has two legs that come down. Now, this is a lowercase pi. It's a Greek letter, and it's a lowercase Greek letter. It turns out that it actually should be about the same size as any other lowercase letter that we have, like the same size as your A. I know mine's a little bigger here just to be able to see it, but should be normally about the size of a lowercase letter. So that ratio that we were talking about, circumference to diameter, so the ratio of circumference to diameter will always equal pi. So we know that this is going to be 3 plus a little more. Now it turns out that irrational numbers, while true, just aren't very helpful in the real world. Using a symbol isn't always super helpful. I need numbers. I need something that I can actually add, subtract, multiply, divide, do whatever I need to do. So what we often do with irrational numbers is we take them and we round them off. So I'm sure some of you are already ahead of me. So if we're 3 and then a little more, one approximation, the most popular approximation of pi, is 3.14. So 3 diameters go around plus a little extra. 0.14 is the little extra. Occasionally we do represent this by rounding it off using a fraction. And when we do, we usually use the fraction 22/7. This is not as common, and I will say on the homework, do not use this unless you are told to. So we use the 3.14 unless we're told to use that. All right, and with that, let's go ahead and flip the paper over and let's take a look at what we can do with this. So if we take our ratio that we discovered and rearrange it, ta-da! We get this formula. And this is a formula that you need to memorize. So C stands for circumference. Remember that typically when we're talking about something that we would calculate, it's usually a capital letter, so hence a capital C here, because we're going to calculate the circumference. And it equals pi. Notice it's the same size as your typical lowercase letter. So pi, we're going to usually approximate. We'll talk about exactly what we're going to do in a second. Times d for diameter. So let's take a look at our first example. Let's say we have a circle, and it's marked like this. So first of all, we got to ask ourselves, what is it that we know about this circle? So since this segment goes from circle to circle, that's a diameter. So we know here that the diameter equals 30 inches. So we're actually going to find the circumference 3 different times. The first time, we're going to approximate using 3.14. So in order to do that, what we're going to start with is C in my formula. So I'm trying to calculate C. And it says C equals pi d. So pi, we're going to approximate. Now, since pi symbol and 3.14 are not exactly equal, it's approximate, this means down here in my work, if I don't use the pi symbol, this will also be approximately equal to. So this is approximately equal to then, the formula says pi, so I'm going to write in 3.14 because that's what we're replacing pi with. And then times d. D here we know is 30 inches. And now we just do what it says. So if this is approximately equal to, then this still is. And if we take 3.14 and times it by 30, we get 94.2, and the inches tag along. So this is approximately 94.2 inches around, or at least it would be if it was written to its full size. So that was pretty simple. Let's go ahead and use 22/7 and see the difference that makes here. So again, C is the first thing in the formula, equals pi. Now we're not going to use the pi symbol. We're going to approximate it, so that means this is going to be approximately equal to as well. And so for pi, this time we're using 22/7, and then times d, which is 30 inches. So in order to do this, I have a fraction times a whole number. I'm going to need to change that whole number into a fraction as well, which is easy. I just put it over 1. We can take a look, see here if we can reduce before multiplying. That would be helpful if we could. Unfortunately, 1s are completely reduced, so we're not going to be able to reduce the 1. And then 7 does not reduce with 22, and 7 does not reduce with 30. So we're just out of luck. We're going to have to just go ahead and multiply and simplify this. So C is approximately equal to, now 22 times 3 would be 66, so 22 times 30 would be 660, and since that had inches, this has inches, and then 7 times 1 is 7. Fractions mean division, so let's go ahead and divide, and this is where I would recommend that you use your calculator to help you out for the sake of time. So if we divide 660 by 7, you're going to end up with 94 point, and then you're going to see a bunch of digits and they're going to fill the rest of your screen, which suggests that this goes on and on forever. And it does. It is going to be a repeating decimal. Well, you're not allowed to use repeating decimals, so we got to get around that. So we know, though, the whole number. We know it goes in 94 times. So what we're going to do is we're going to think Thanksgiving. Remember that in fractions, you can think of the numerator as how many pieces we have, or if you think about Thanksgiving, about pi, as how many slices we have. So if we have 660 slices, then the denominator tells me how many slices it would take to make a full pie. So how many times does 7 go into 660? Well, it goes in 94 times. That's 94 full pies that you would have made. So if we take 7 slices, put them together in one pie, another 7 slices, put them together in another pie, and keep going and going and going, you'll have 94 full pies. So I need to know how many slices did this take. Well, if there are 94 full pies and 7 slices in each pie, so these two numbers multiplied together, that will tell me how many slices this took. So multiply those together, use your calculator. It would have taken 658 slices to make my 94 pies. So how many slices then are left over that don't make a full pie? Well, we started with 660. We took 658 to make full pies. There are 2 slices left over, which means that 2 then, oh, sorry, don't need another equal sign. Fraction bar is what we need. So that 2 will become my new numerator. 7 is still the denominator, and inches are my units. So you'll notice these two answers here actually are pretty close. 94 with something extra, 94 with something extra. So they come out about the same. However, if we consider which one of these was easier to do, that was much easier. So this right here, this problem, this was really not the time for 22/7. The 22/7 really just made that problem harder, not the time to use it. Well, ladies and gentlemen, because we use the approximately equal to signs, both of these examples are only approximate answers. They're just approximate answers. They're not exactly correct. They're close though, but not exactly correct. So now we're going to take a look at how do we find the exact answer? Well, remember that this is equal when we use the pi symbol. The pi symbol represents that entire irrational number, all those non-repeating digits, all of them, all at once with this symbol. So in order to get an exact answer, we have to keep using the symbol. So we start with C. And since this is going to be exact, it is going to actually be equal. It's not going to be approximate. It's going to be exactly equal. Like I said just a moment ago, we have to use the pi symbol. And then we multiply by our diameter. Diameter here is 30 inches. And now we simplify. Now, since I'm using a pi symbol here, there's not a ton of simplification I can do, but I do need to do a little quick rearrange. So we will have circumference equals, and when we have a 30 and a pi in inches, it goes in this order: 30 pi inches. So the order here is number, pi, units. And that's my exact answer. Now, one of the benefits to an exact answer is if I'm working with multiple people and maybe somebody needs this to be rounded off to a certain point, 3.14 will work for them, then they can go ahead and decide to replace pi with 3.14 and get their approximate answer. Now, let's say somebody else really doesn't need it to be that close, and they can just approximate pi as 3, and that's good enough for their purposes. Well, then they can do that, and they can see that it would be about 90 inches. It's not as accurate, but it might be good enough for them. Maybe somebody else needs it even more exact, and so they need more digits of pi. And so maybe they approximate pi as 3.14159. They have the option when I hand off an exact answer. That's one of the benefits. There are other benefits that as we start getting more into algebra, we'll start to see those, but that is the exact answer. So if the book ever asks for the exact answer, if it uses the words exact answer, this is what you'll do. If it just says find the answer or find the circumference, this is what you'll do. And if it tells you to find the circumference and use 22/7, this is what you'll do. All right, with that being said, let's go ahead and take a look at one last example here, and then we will be done with this lesson. So again, when you look at your circle, first thing you got to do is take a look at what's marked and think about what is it. So this segment here that's marked as 14 feet is going from the center to the circle. Well, something that goes from the center to the circle is a radius. So this time, 14 feet is a radius. So to find the diameter, remember that diameter is 2r. So this is going to be 2 times 14 feet. So 2 times 14, diameter is 28 feet. So this is what I'm going to use. Most common error that I see students make on problems like these is they end up with a radius and they try to use that in the formula, but the formula doesn't say r, the formula says d. So if you end up with a radius, you got to change it into a diameter. So multiply by 2. All right, we're going to do this again. So this time, start with our formula. So C equals pi d. So we start with C, but since this is only going to be approximately equal, this will only be approximately equal. Then times d. Well, we just figured out that d was 28 feet. And if we go ahead and figure that out, 3.14 times 28, we should come up with 87.92. And since this was feet, it tags along feet. 87.92 feet. Moving on here, use 22/7. So again, I'm going to say C, and since this is approximately equal to, this will be approximately equal to when I use the 22/7. times d. D in this case is 28 feet. Just as we did before, we're going to change our whole number into a fraction. So throw it over 1. And then it's helpful here to look and see, can I reduce this before multiplying? So 1s can't reduce. A 7 does not reduce with a 22. However, a 7 does reduce with a 28. So if I reduce my 7 and my 28 by 7, 7 goes into itself once, 7 goes into 28 4 times, and now I have all 1s on the bottom, which means that my answer is going to be a whole number. So 22 times 4 is 88, and feet are my units. Now if we compare these two, you'll see that these are very close. If you want to get a real feel for how close they are, it might be helpful to pretend that the feet aren't there and pretend that they have a dollar sign in front of them. So $87.92 compared to $88, that's like 8 cents difference. So it's not actually 8 cents, but it's like that. So if you understand the money comparison, you should understand the length comparison here. They're pretty close. Finally, let's, before we move on to that. So what we see here is because this can reduce, this was a good time for 22/7. So we typically use 22/7 when we have the opportunity to reduce before multiplying. So usually that's going to mean that my diameter is a multiple of 7. It can be reduced by 7. That's a good time for 22/7. All right, finishing it off, find the exact answer then. So just like we did up here, we start with C, and this time because we're continuing to use the symbol, it's going to actually be equal. As long as we continue to use the symbol, it actually is equal. Anytime you replace it with something it's approximately equal to, then this ends up being approximately equal to. So pi times d, d in this case we found out was 28 feet. And then it's just a matter of putting it in this order. So number, pi, units. 28 pi feet is my exact answer. So one last time, remember that if you're told to find the circumference, this is what you're doing. If you're told to find the circumference using 22/7, this is what you're doing. If you're told to find the exact answer, the exact circumference, this is what you're doing. And that, ladies and gentlemen, is the end of our lesson.